High potential testing, also known as high-pot testing, is a crucial procedure for assessing the integrity of medium voltage cable insulation. This process involves subjecting the cable to a voltage significantly higher than its normal operating voltage to identify any weaknesses or defects in the insulation. Following are procedures for high potential testing of 13.8 kV medium voltage cable. You will need the following materials. Firstly, a high pot tester rated for 13.8 kV or higher. Secondly, test leads. Thirdly, insulating gloves and protective clothing. Fourthly, a multimeter. Fifthly, a temporary grounding rod or clamp. Ensure the following safety precautions are followed. Firstly, ensure that all electrical equipment is de-energized before testing. Secondly, wear appropriate personal protective equipment including insulating gloves, safety glasses, and grounded footwear. Thirdly, perform the test in a well-ventilated area. Fourthly, keep all personnel away from the test area during testing. Fifthly, use only equipment rated for the voltage being tested. Now here is the test procedure. Step 1 is preparation. Firstly, clean the cable terminals and connect the test leads securely. Secondly, ground one end of the cable using a grounding rod or clamp. Step 2 is voltage ramp up. Firstly, gradually increase the voltage from 0 to 13.8 kV at a rate not exceeding 2 kV per second. Secondly, monitor the current using a multimeter connected in series with the cable. Step 3 is hold time. Hold the voltage at 13.8 kV for 1 minute. Step 4 is voltage ramp down. Gradually decrease the voltage to 0 at a rate not exceeding 2 kV per second. Step 5 is insulation resistance test. Use a multimeter to measure the insulation resistance between the conductor and the sheath. A reading of at least 500 megohms is acceptable. Step 6 is dielectric absorption test, which is optional. Firstly, after holding the voltage for 1 minute, discharge the cable for 10 minutes. Secondly, reapply the voltage to 13.8 kV and hold for 2 minutes. Thirdly, note the current readings at the beginning and end of the hold time. Evaluation of results. If the insulation resistance is less than 500 megohms or if the current exceeds 1 mA during the hold time, the cable may be faulty and should be further investigated. The dielectric absorption test can provide additional information about the insulation condition of the cable. A high absorption ratio, which is the current at the end of the hold time divided by the current at the beginning of the hold time, may indicate moisture or other issues within the insulation. Additional notes include: firstly, perform the test on all 3 phases of the cable. Secondly, if any abnormalities are detected during the test, the cable should be repaired or replaced as necessary. Thirdly, keep a record of the test results for future reference. The purpose of a high-pot test is to verify the integrity of the insulation in the electrical cables and equipment. It helps detect any weaknesses, defects, or potential failure points in the insulation before they lead to equipment failure or safety hazards. By applying a high voltage, typically direct current or alternating current, the test stresses the insulation beyond its normal operating conditions. This stress can reveal hidden flaws such as cracks, pinholes, contamination, or degradation that might not be apparent under normal voltage levels. The basic principle behind a high-pot test is to measure the current that leaks through the insulation while it is subjected to the high voltage. A healthy insulation should exhibit very low leakage current. If the leakage current exceeds a predefined threshold, it indicates a breakdown or weakness in the insulation. There are several types of high-pot tests, including firstly the dielectric withstand test, which involves applying a specific voltage for a set duration to verify that the insulation can withstand the voltage without breaking down. Secondly, the insulation resistance test, which measures the resistance of the insulation to determine its quality. Higher resistance values indicate better insulation. Thirdly, the step voltage test, where the voltage is gradually increased in steps to observe the insulation's behavior at different voltage levels. Fourthly, the ramp voltage test, where the voltage is continuously increased at a steady rate until breakdown occurs. The procedures and voltage levels for high-pot testing are typically defined by industry standards such as those from the Institute of Electrical and Electronics Engineers, commonly referred to as IEE. the International Electrotechnical Commission, commonly referred to as IEC, and the National Electrical Manufacturers Association, commonly referred to as NEMA. These standards specify the test parameters, including the voltage levels, test duration, and acceptable leakage current limits. The choice of voltage for a high pot test depends on the equipment's rated voltage and the applicable standards. Generally, the test voltage is higher than the equipment's normal operating voltage to provide an adequate safety margin. For example, a common rule of thumb is to use twice the rated voltage plus 1000 volts direct current. However, specific standards should always be consulted to determine the appropriate voltage level. High pot tests are commonly performed on a variety of electrical equipment and systems, including firstly, cables and wires to verify insulation integrity. Secondly, transformers to assess winding insulation. Thirdly, motors and generators to check stator and rotor insulation. Fourthly, switchgear and circuit breakers to ensure insulation withstand. Fifthly, appliances and electronic devices to meet safety standards. When performing a high pot test, it's essential to follow several safety precautions to protect the testing personnel and equipment. Firstly, ensure that the equipment under test is completely de-energized and isolated from the power source. Secondly, use appropriate personal protective equipment such as insulating gloves, safety glasses, and grounded footwear. Thirdly, keep unauthorized personnel away from the test area. Fourthly, use a high pot tester with built-in safety features such as automatic shut-off and overload protection. Fifthly, ground the equipment under test to provide a safe path for leakage current. Sixthly, perform the test in a controlled environment free from moisture and contaminants. The interpretation of high pot test results involves analyzing the leakage current and voltage readings to assess the insulation's condition. A sudden increase in leakage current or a voltage breakdown indicates a failure in the insulation. The acceptable leakage current limit varies depending on the equipment and the applicable standards. Generally, a lower leakage current indicates better insulation quality. If the leakage current exceeds the limit, the equipment may need to be repaired or replaced. High pot testing is used in quality control during manufacturing to ensure that electrical products meet safety and performance standards. It is also used in maintenance and troubleshooting to detect insulation degradation and prevent equipment failures. By identifying potential issues early, high pot testing helps improve the reliability and safety of electrical systems. There are some limitations to high pot testing, including firstly that it is a destructive test, meaning that it can potentially damage the insulation if the voltage is too high or the insulation is already weak. Secondly, it only tests the insulation's ability to withstand voltage stress and does not assess other factors such as mechanical strength or chemical resistance. Thirdly, it may not detect all types of insulation defects such as partial discharges or surface contamination. Despite these limitations, high pot testing remains a valuable tool for assessing insulation integrity and ensuring the safe operation of electrical equipment. The frequency of high pot testing depends on the equipment type, operating conditions, and applicable standards. Generally, critical equipment should be tested more frequently than non-critical equipment. Some standards recommend high pot testing every 1 to 3 years for high voltage equipment. Routine visual inspections and other non-destructive tests can also help identify potential insulation issues. To conduct a high pot test effectively, it's important to have a good understanding of electrical safety principles, testing procedures, and applicable standards. Proper training and certification are essential for personnel performing high pot tests. It's also important to use calibrated and well-maintained testing equipment. By following best practices and adhering to safety guidelines, high pot testing can be performed safely and accurately to ensure the reliability of electrical systems. In addition to the basic high pot test, there are several variations and specialized tests that can provide more detailed information about the insulation's condition. These include firstly, partial discharge testing, which detects and measures small electrical discharges that occur within the insulation. Partial discharges can indicate insulation degradation and potential failure points. Secondly, dissipation factor testing, which measures the energy losses in the insulation due to dielectric polarization. A higher dissipation factor indicates increased losses and potential insulation problems. Thirdly, time domain reflectometry, commonly referred to as TDR, which uses electrical pulses to locate faults and discontinuities in cables and wires. TDR can help identify the location of insulation defects. Fourthly, frequency response analysis, commonly referred to as FRA, which measures the insulation's response to different frequencies of alternating current voltage. FRA can detect changes in the insulation's structure and composition. These specialized tests can be used in conjunction with high-pot testing to provide a more comprehensive assessment of insulation integrity. The choice of test depends on the specific equipment and the type of insulation defects being investigated. In the context of 13.8 kV medium voltage cables, high-pot testing is particularly important due to the high voltage levels and the potential for significant safety hazards. Medium voltage cables are used in a variety of applications, including power distribution, industrial plants, and commercial buildings. The insulation in these cables is subjected to high electrical stress, temperature variations, and environmental factors. Regular high-pot testing can help detect insulation degradation caused by these factors and prevent cable failures. When performing high-pot tests on 13.8 kV cables, it's important to use testing equipment specifically designed for medium voltage applications. The testing equipment should have sufficient voltage and current ratings to safely test the cables. It's also important to follow the manufacturer's instructions and applicable standards when performing the tests. The test voltage for 13.8 kV cables is typically in the range of 20 to 30 kV direct current or 10 to 20 kV alternating current, depending on the cable type and the applicable standards. The test duration is typically 1 to 5 minutes. The acceptable leakage current limit is typically in the range of 1 to 10 microamps per meter of cable length. After performing the high-pot test, it's important to carefully inspect the cable for any signs of damage or degradation. This includes checking for cracks, swelling, discoloration, or other abnormalities in the insulation. If any defects are found, the cable should be repaired or replaced. In addition to high-pot testing, other non-destructive tests can be used to assess the condition of 13.8 kV cables. These include insulation resistance testing, partial discharge testing, and time domain reflectometry. Insulation resistance testing measures the resistance of the insulation to direct current voltage. A lower resistance value indicates insulation degradation. Partial discharge testing detects and measures small electrical discharges that occur within the insulation. Partial discharges can indicate insulation degradation and potential failure points. Time domain reflectometry uses electrical pulses to locate faults and discontinuities in the cable. TDR can help identify the location of insulation defects. By combining high-pot testing with other non-destructive tests, a comprehensive assessment of the condition of 13.8 kV cables can be obtained. This information can be used to develop a maintenance plan that ensures the reliability and safety of the cables. The frequency of high-pot testing for 13.8 kV cables depends on the cable type, operating conditions, and applicable standards. Generally, cables installed in harsh environments or subjected to high electrical stress should be tested more frequently than cables installed in benign environments. Some standards recommend high-pot testing every 1 to 3 years for 13.8 kV cables. Routine visual inspections and other non-destructive tests can also help identify potential insulation issues. Ultimately, the goal of high-pot testing and other insulation assessment techniques is to ensure the reliable and safe operation of electrical equipment and systems. By detecting potential insulation defects early, equipment failures can be prevented and the risk of electrical hazards can be reduced. Proper training, adherence to safety guidelines, and the use of calibrated testing equipment are essential for performing high-pot tests effectively and safely.